Hello, welcome to this webinar. As Al said, it's great to see so many people coming along to find out more about Flood Platform. I'm Adam Parks. I'm the Technical Director for Digital Flood Products at Jacobs, but I am a hydraulic modeler and hydrologist with over 20 years experience in the industry, and that's mainly been focused on building models and undertaking analysis for flood mapping, flood risk mapping, for flood defense design, for scheme appraisal, for flood forecasting, and a range of other uses. So I'm really familiar with the challenges and the issues we have with managing large amounts of model data in our industry, as well as being exposed to what we can do better, how we can do this better. And that's why I'm really excited about Flood Platform and showing you what it can do and how it can address some of the key challenges we're facing. This webinar is really focused on visualizing model results. So once you've uploaded your results for a platform, how can I interact with them? How can I share them? How can I review them? How can I show them to my colleagues, my clients, and stakeholders? And that's what I'll be taking you through in this webinar with some live demonstrations a bit later on, really getting under the hood of how that works and what you can do with it. So in this webinar, I'll look at a number of things. First off, I'll do a quick reintroduction to what Flood Platform is. So look at the challenges we face as an industry and how Flood Platform addresses these challenges. I'll give you a quick overview of what Flood Platform can do, touching on some of the functionality I won't be looking at in detail as part of this webinar. And then we'll get into some live presentations. So I'll be showing you how to manage your modeling data within Flood Platform, how you can upload large data sets to Flood Platform, and how that manages that data. Once the data's up there, how you can visualize your model data. You can look at your results, whether it be 1D or 2D, Flood Modeler or TUFLOW, all within Flood Platform. And as an extension to that, how you can review your results, how you can do deep dives into your model data, provide comments, identify problems, and also share your results, both with people within your organization, so your colleagues within the same modeling team or the same organization, as well as other organizations you may be collaborating with, or ultimately clients and stakeholders. As Alistair said, at the end, we've got time for some Q&A, so if there are any points I've not addressed through the webinar, please feel free to put them in the questions box in GoToWebinar, and we'll answer as many of those as we can at the end of the session. So what is Flood Platform and why have we built it? Flood Platform has been designed using Jacobs' extensive experience of flood management across the globe, our experience of product development, as well as our continued research into practitioner needs. And the key thing we've asked when we designed Flood Platform are, what do users need? What challenges they faced? And we've asked this of users, practitioners, clients, stakeholders from across a range of backgrounds and geographies, and we received remarkably consistent feedback. And that feedback's mirrored my own experience, the challenges we have within the industry about managing data, managing simulations, and undertaking things in more efficient and effective ways. And we can really break these challenges down into four broad categories. The first one is collaboration. It's recognized by everyone in the industry that collaboration is essential to achieving the best outcomes from our work, providing team members, colleagues, partner organizations, and clients access to our model results. This allows them to provide comment, to undertake review, to dive into those results and understand them, to have that continuous feedback cycle. But this is often stifled by the sheer size and complexity of our models and the tools available to us. It's easy enough to share a few megabytes worth of data backwards and forwards, but when we start moving into sharing gigabytes or even terabytes of data, it's the size of our models, the complexity of our models are a real hindrance to that collaboration, that continuous feedback. And so that's one area which Flood Platform addresses, and I'll be showing you today. Allied to that, we've got data. Our models are getting so much bigger. When I first started industry, the models were in the megabyte range, hundreds of megabytes. Now we're into the many, many gigabytes, terabytes of data. We've got projects which will quite happily move into the petabyte range in the coming years. So managing that data is essential. Where do I store it? Where is it located? How do I move it around? If I've got a couple of terabytes worth of data, how do I transfer that to a client so they can host it on their system? How do they host that much data? And associate that, how do I interrogate that data? There's no point having a massive zip file on a file share somewhere if you can't interrogate that information, you can't visualize what's in there. And that's where Flood Platform really shines, and that's what I'll be showing you throughout the rest of this webinar, how you store that data, manage it, and also visualize and understand it. Also associated with that is how do you archive data at the end of projects and also restore it when needed. Technology, we have seen some massive shifts in technology during my career, but certainly over the last 5 years, we've seen the rise of really good data science tools. We've got machine learning and AI, and they're really impressive. We can see the opportunities they bring to make our work more effective and to provide better outcomes, to get things done right first time, reduce rework, free our teams up to spend more time analyzing their results and building things rather than doing the nitty-gritty manual work. And what we want to introduce with Flood Platform are a wide range of automation tools which avoid and reduce the amount of manual work required in modeling. So that could be calibrating and optimizing models, managing your simulations, managing your licenses and compute resource, fixing models and identifying problems. Anything we can automate, we will. And what Flood Platform allows is a structured way of storing your data, which allows us to build these automation tools. And finally, but probably most importantly, we've got security. To me, security around data is broken into two parts. The first bit, and we often think about this for web-based services, is access control. How do I make sure only the right people can access that service, can access my model data, only the right team members have access to specific projects or can spend money on compute? That's essential, and that's really baked into Flood Platform, and I'll show you that in a minute. The other part about data security is making sure we can keep hold of our data. I'm sure I'm not the only person to have come across projects which have produced very large amounts of model data, and the expectation is that's too large to be stored on a network, on a file share or elsewhere, and it ends up on an external hard drive in a drawer somewhere. You come back to that drive in 4 or 5 years' time, or in 6 months' time, and the drive's been damaged, it's corrupted, the encryption key can't be found, or there's some other reason you can't access that data. What Flood Platform does, it gives you confidence your data is secure, it's stored in the cloud, it's backed up, and it will always be accessible. You don't run the risk of losing your data. And those are the two parts of data security. Flood Platform addresses all these points. We've been using it internally within Jacobs the last 15 years. It's evolved dramatically in that time from what it started out as to what it is now. And we want to make it available to everyone as a standalone product, covering initially Flood Modeler and TUFLOW, and in the coming months expanding to HECRAS, EPA SWIM, and other solvers as we progress. The core functionality in Flood Platform, I'll show you a lot of these shortly, is around model management, so that data management piece. How do I store and manage, find my models, a key problem. Visualization, I'll be showing you how you visualize your results in the platform or within a web interface. Simulation and analysis, so if I want to run my model 10 times, 100 times, 1,000 times, 10,000 times, how can I do that? How can the cloud allow me to do it? Increasing reporting, so generating standardized reports and deliverables from your data. And importantly, collaboration. How do I share my models and data with other people within my organization and externally? And doing all this, how am I confident that the security of my data is maintained? How can I demonstrate compliance at the same time? Final slide before I jump into the demo. So Flood Platform is a cloud-based solution, and whether you're a model creator, so you're an originator for modeling work, a stakeholder, a client, everyone accesses the system via a single secure gateway. So this is a web-based gateway where you enter your user credentials, you pass through two-factor authentication, and you can access the platform. Once you're in the platform, you've got access to a huge range of tools and processes which allow you to manage your models and your model data better. And I've touched on some of those, including model uploads, a spatial model catalog, simulation running, visualizing your reports, report builder, reviewing feedback, QA, and so on. And we're building these up as we go. So we've got the core functionalities already in place, and we've got ambitious plans to add more functionality in the coming weeks and months. Underpinning all these functions are our core functions around data storage. We're using cloud, so we've got effectively unlimited data storage for you to store your data. We've got those automations I mentioned, so automated QA, automated model processing, sharing, and so on. Our modeling applications, including Flood Modeler, TUFLOW, and soon to be HECRAS and SWIM. As with cloud, unlimited GPU and CPU compute where you really need it, and also increasing use of machine learning and AI to draw further information out of your models to automate as much as we can, making you more efficient and giving you more time to focus on the quality of your outcomes and analyzing your results rather than doing the mundane manual elements of flood modeling. Right. So I'm going to jump into a demo. What I'm going to do is show you using Flood Platform through a series of different model types, showing you how you manage that data within Flood Platform, how you visualize the data. As I say, when you first log on, you'll be presented with a splash screen, a log-on page where you enter your credentials, and there's a two-factor authentication piece as well to make sure you are who you say you are and ensure your model data is secure. Once you're through that, you can jump into the platform. So this is Flood Platform live on my computer, and I'm going to launch the dashboard. So dashboard is where you store all your models and your projects. I've got an awful lot in here because we're doing a lot of testing with Flood Platform with different model types, different geographies, and so on. And the first thing you see are these, what we're calling workspaces, where you have a collection of projects all together. So if I click on this one down here, for instance, this is a workspace that contains multiple projects. And a workspace may be for a particular client. You may have all the work you do for a local authority or a council under one workspace. It may be geographic, so maybe all the UK teams have all their projects under one workspace or some other organization. But this is where you can access your individual projects and your individual models. I'm going to dive into these in a bit more detail in a second. Before I do that, I just want to touch on finding your data. A key challenge I've encountered, certainly with data held by Jacobs, but also by our clients who commission a lot of modeling work, is actually finding your models. Where have I worked in the past? And so the way we handle the data in Flood Platform includes the ability to find existing model data. So this is our globe view. You can see you've got models all across the world. We zoom back in on the UK. You can see where we've got demo models already set up within the UK at multiple locations. And the one I was going to look at today is this model package 4. So I click on that. It shows the spatial extent of that model package. So I can see where I've been working. It's highlighted that model package. I can zoom in on that. And I can also see the individual projects within it. So I can switch those on as well. So they've now popped up. So I can see I've got a fluvial modeling project up here at Upton and a coastal modeling project down here at Clevedon. And again, if I click on those individually, I can see the spatial extents. And from here, I can jump straight into those models as well. So the global catalog is really there as a tool to help you find your modeling data. It's about discovery rather than to rummage around hard drives and project servers or asking people. Anyone can, once you've uploaded your models to Flood Platform, you can find them easily, understand where they are and what's been done. Going back into that package I had a second ago, this is a simple package with a couple of projects in it. And to create a new project is really easy. You just click Create New Project, give it a name. So webinar demo, give it a description. I'll put some tags in here. So this is going to be a coastal model. It's going to be at Clevedon, and it's going to be in the UK. So these tags help, again, me search data out later on and understand what that data is. I can provide quite large descriptions. And I also want to put a geofence around this. So I'm going to put a box on my map which defines where my project is to help me find it later on. So rather than to search through files and folders. That's already been created, add to my project. I can now upload a model. So this is going to be a pure TUFLOW model. I can define the source of flooding. So in this case, coastal. It's a pure 2D model. I give a description. And again, this is all optional, but it gives you the ability to categorize your model data as you receive it. It makes it far easier to find in the future. And now I can upload my model. I'm going to upload this simple 300 meg model on a home broadband connection, so this will take a few minutes to upload. And we've been practicing uploading models in the sort of many gigabytes range. I was uploading one last night, which was about 50 gigabytes. It took about an hour to upload. But once the data has been uploaded, Flood Platform processes that data, analyzes it, and makes it available for you to visualize. Whilst that's uploading, I'm going to jump over to one I uploaded earlier. So it's the same model data which I uploaded. I can jump into it. So what Flood Platform's done is uploaded the zip file, it's decompressed it, it's scanned through all the files and made them available to me. It's also done some checks to see if there are any missing files on the upload as well. So I click on the checks. There's a load of missing data in here because there's some results files missing. This was done intentionally to test the system, but I can see there's data missing within my uploaded zip, so I can fix that. But it's really helpful when you receive a model, checking what's there. I can also look at the component files. This TUFLOW model, so it comprises of a lot of text files. If you use TUFLOW, you'll know what these look like. These are the control files for TUFLOW, so I can see the command files. I can see the batch files as well that have been used to run this model. I can also access the input files. So for instance, this is a coastal model, and we've got all the tidal boundary conditions that have gone into that hydraulic model. And what we're doing is making it easier to understand and interpret these things rather than raw text files. We're presenting them as tables and charts so you can understand them better. But the key thing is getting into some results. So if I jump into some results, you can see this model's been run about 40 times for different return periods and scenarios. I'm going to jump into these. And instantly I can see how well that model's performed. I've got some model performance data, wet cells, mass balance, and so on. I've got access to the model logs. I can see any errors or messages. And then I can also get into the results. So pop that open. This is the 2D map view. So I can see there's Clevedon. I can switch between a map view and a satellite view, so I get different perspectives. And down the left-hand side, I've got results and check files. So the checks allow me to see things like the DTM, so the digital terrain model that makes up this model. I can see things like the grid check file as well, so I can see how big the model was and where the cells are within it. So this all helps with model review. But I want to see some results, so I can switch on flood depths, for instance. This model takes a little while to, there we are, there's the flooding started, and I can then animate through those results and see where flooding happens within Clevedon. If I zoom in a bit, you get a better view on that. I can also switch on the velocity arrows so I can see the direction which water is flowing across the system and really zoom down into the local level of what's going on. And Flood Platform allows you to do this no matter how big your model sizes are. So we've got a few which we got results of several gigabytes for a single simulation, and they render really well in Flood Platform as we process the data behind the scenes. Switch those off, and I can also jump straight to the max flood extents as well. I can interact with this data. I can pull up level data information, any of the parameters that have been run through the simulation. I can extract screen grabs. There's a tool there to export this stuff as PDFs or PNGs with scale bars and so on. And also I can put comments on. So I can see here this model stops abruptly over here. There's clearly a glass wall going on, so I can put a comment on here along there's a. So as I'm reviewing the model, I can add comments as well. It may be also that this brook down here, this is the blind geo. So if I'm a reviewer of this model, I can apply comments and I can share these comments with people in my team or external users as well. So I can add other users onto this project to access this data. So this is a pure 2D model. So these, it's very easy to see this without specialist software. The next I'm going to have a look at is a pure 1D model. So this is one of our demo models, Upton Pond 7. So this is a pure Flood Modeler 1D model. So I just jump into this. As before, I've got access to all the input files in here. I've also got the upload checks, but I've got the simulations. This is a 1D model that's been run for 4 different return periods. I can just click on one of these and pop that open. And as with TUFLOW, Flood Modeler displays the key diagnostic information, so I can see about input outputs, mass balances, convergence, all in one place, as well as the input files, the simulation. All the data is sorted and accessible, and I can view the results as well. So pop that open in another window. So this is Upton upon 7, zoom out a bit, so this Clevedon's down here, this is Upton, zoom in a bit, and as I get close enough, the icons will switch to standard Flood Modeler icons as well. Just switch that to map view, looks a bit nicer. So I can see the extent of my 1D model, where my nodes are. This is a very simple model, mostly cross sections, but I can start to interrogate it as well. So for instance, I can click on these cross sections, and what I get is a cross-section profile in red and the stage profile, so the flood level in blue. And I can carry on clicking on these, and it will carry on adding those onto my display. And what I can do is pop that out as well, so I can have that as a separate window. So if I'm working on multiple screens, I could park this on another screen, and it will interact, manage the interaction between my map view and my tabular view over here. We pull all the data out of the 1D models, so stage, velocity, flow, errors, conveyance, and so on. In this version, we're currently only showing the stage, but we'll be introducing all those other profiles and data in the next couple of weeks ahead of launch. We'll also have the ability to plot long sections and other time series data the same way you do in Flood Modeler. So you've got the same functionality in Flood Platform as you will do in Flood Modeler, giving you access to all the data you need to understand your model results. So I've shown you a pure 2D model, a pure 1D model. Let's just finish off by looking at a linked 1D 2D model. So this one's over in Australia. This is down on the East Coast. And let's just launch this up as another simulation. So this is a linked Flood Modeler, linked TUFLOW ESTRY model run in HPC. I think I may have just merged my internet connection. Let's try that again. Oh, there, it's popped open now. Whilst it's loading up, I'm just going to. So again, I've got all the information about how that model's performed. This is a HPC model, so I've got the computational efficiency as well, all the mass balance and other information down here. And finally, I'm going to view the results of this model. I'm going to close down a few other windows because I suspect I'm stressing my browser a little bit having all those results open. There we go. Let's give that a second to load. The joys of live demos. There we go. So this is a linked TUFLOW ESTRY model, and the difference compared to the previous one is I've got both 1D and 2D results in here. So I can switch on my culverts and my channels. So in this case, I've got a culvert network over here, and I've got a channel network over here, as well as my 2D. I'll switch on my 2D depth plots as well quickly and maximize that. So if I want to see the results of my 1D model, I can click, there's the 2D just popped on there, so I can click on these components and open those up. There we go. So on the right-hand side, this will be loading up my my culvert details. It's taking a little while to load. I think I may have somewhat overstressed my computer. Oops, sorry, give me a second to get that back. Excellent, joys of live demos. This was working immediately before I had started up, so I think I may have broken my browser. There we go, it's woken up now. So what I can do is I can click on my culverts. I can see the culvert dimensions. So I can see it's a pipe, the length of the pipe, the roughness, the upstream and downstream invert. I can also see the flow in the pipe as the dashed line and the up and downstream water levels calculated in that pipe. This other one over here I clicked on is a channel. So in this one I can see the channel profile. That's the red line here. So that's the cross-section profile, as well as the flow, upstream and downstream water levels as well. I'm not sure if you're familiar with using ESTRY models, but they're really challenging to pull a lot of this data out of, and Flood Platform makes it really easy to access the results and to visualize them in an easy way. I'm just going to jump back into my presentation. We've got a few minutes left, but I'll just quickly say, so I've really focused on the visualization and data management elements of Flood Platform. We'll have future webinars which will look in more detail about simulation analysis and other components as well.